the add button. And this will be the print button. Alright, so we have our controls in place. What we need to do is wire up to the click event on the add button. Double click on add. Brings up our event handler method. What we can do here is we can unpack the values out of those text boxes and put them into a class. Now before we can do that, we actually have to create our class. So Solution Explorer, right click, add, class. I'll call this a user. I'm going to go ahead and make it public. And I'm going to add 4 properties. First name, last name, email, phone number. Okay. So with that class, I can declare user u equals new user. That user then comes with these properties, all public. Email address, first name, last name, phone number. It also comes because it inherits from object as equals, get hash, get type, into string. Those methods can then be overridden within our class implementation to give us additional functionality. So u.firstname equals txtfname.text. u.lastname equals txtlastname.text. u.phone number equals txtphone.text. And then u.email equals new mail address of txtemail.text. Yes, the mail address will actually validate the text to ensure that it complies with the structure of the email address. Doing this, if this is an invalid string of text, you'll actually get an exception from the constructor of mail address saying that this isn't a correctly qualified or defined string. So, because of that, we probably would want to wrap this inside of a try-catch block. In case it's not a valid email address, and then we can do message box dot show email address is invalid. Please verify. Return. Exit event handler. No save. Okay. Scroll up a little bit so you guys in the back can see it. Kick it up a notch. Okay. If we wanted, we can actually take the exception object, the EX, and we can include those details in our message box. Put the message in there to give you just some more formality, more detail about it. So up to this point, we've created a user, captured string data, capture the email address, handle invalid emails, and then the next step is we need to take that, we need to save our user data into a collection. So when we talked last week, we talked about the different types of objects within the system.collections namespace and system.collections.generics. Talked about array lists and stacks and queues and dictionaries and hash tables. We went through all of that, some in more detail than others. What I'm going to do is I'm going to build a custom collection. So what I'm sure many of you did is you did list user list equals new user list, right? Quick, simple, easy, and it works. And it works very well. This is not a bad implementation. There's nothing wrong with doing it that way. I'm just going to show you an alternative way. So let's say that I wanted to have some unique functionality with my collection that the list doesn't provide. I don't want to ensure that every user that I put into my collection is unique. That list will not check for that. That list is just going to allow you to add users to the collection. Simple, easy, direct. I want to verify that no two users are in that collection that have the same email address. That's my goal. Now, we could do that using the list, but what we'd have to do is we would have to have our list, and then we'd have to do a for loop, or a for each loop. And every time we'd have to iterate over that to ensure that we don't have duplicates. That can get pretty tedious. It's a lot of extra cycles that the computer has to go through every time you add a user. If you think of this as a high-performance environment where you're potentially collecting hundreds or thousands of users every second, Facebook, LinkedIn, Twitter, you want to be able to quickly, almost instantly, check for that email address and see if it exists. Now, also in those environments, you probably have these huge databases and many servers to manage all of that, but all things being equal, we want to try to emulate the same performance. So I'm going to go ahead and I'm going to create my own class. It'll be my user collection. I'm going to touch a little bit today on interfaces and inheritance, just so you can see it at a high level. And it's really there more for providing functionality. So with the collection, you have basic methods. You have add, you have a get, remove, you can do a check, a verify. So we're going to have public void add, and it's going to expect a user. We will have remove user. Public void get, and maybe we do that by string. Email address. We also may have a mail address. Now these are all empty methods. They don't actually have anything in them. So when so from this side, and sometimes I like to think of classes almost as being people, and they talk to each other, and it helps you kind of build these barriers of scope, so when you make things public versus private. When the form goes to talk to the collection object, things that are public it can see. Things that are private it can't see. So your public and your private play into those roles of accessibility. What am I allowed to see? So the form can only see things that are public by other classes. When I declare a private variable inside of my user object, the form doesn't even know that it exists. And that's by design. I'm trying to encapsulate and protect data that maybe my form isn't supposed to have access to. Or if I wrap all of this code up into a library, into a DLL file, and I share it with someone, I only want them to have access to the pieces that they're supposed to have access to. I don't want them to have access to the proprietary information inside of my project. So at this point, I have user collection. And I need to be able to add, store, track, maintain my users that I'm adding. So I need a collection. I need a space to put that in. So again, from here we could say private list, user data. Simple as that. But now we've replaced one problem for another. We've moved the problem somewhere else. So when we do an add, we still have to loop through this entire collection if there's 1,000 people in there, and we have to check every email address. Not very efficient. What we can use instead is a hash table, or I'm sorry, not a hash table, but a dictionary. In a dictionary that has a key-value pair. Has anybody ever used the key-value pair dictionary before? You want to explain what it is, Adam?
You have the key and then the data that stands for.
Mm-hmm. And what makes it so powerful?
Because you can search by key.
Right. So you have a key, and you have a piece of data. The keys are unique. You can't have duplicate keys within the dictionary. But that key just acts as a reference point to the actual data that you're looking for. So where's the gain in using this dictionary for what we're trying to achieve? You have one spot to look. And intrinsically, it keeps you from having duplicate email addresses if your key is the email address.
What is it? Does it use some kind of hashing function to generate the key? It can't just generate like an auto number.
You can use the hash set or the hash table class if you want to auto-generate a hash.
Yeah.
But if we're wanting to use it for lookup purposes, you want to use the dictionary. Now, your key doesn't have to be a string. It could be an object. So if you wanted to generate a hash of some sort using an algorithm, you want to take an object and generate a hash of that object, you can do it that way as well. So you have flexibility with the dictionary. But the hash set and the hash table will simply basically take the object itself, and it determines whether or not it's a duplicate object or if it's unique based on referential memory addresses. There's a method on every class called getHashCode, and that method, if overridden, gives you the ability to generate your own hash codes for your objects. If you leave it to its own devices, it basically uses the memory address that that variable references and a few other techniques to generate a hash code. They're not guaranteed to be 100% unique, but they're pretty close. So for this dictionary, I'm going to use a string, which will be my email address, and then my user object. I'm just going to call my variable collection. So now I have a private container, a collection, for storing my user data inside of. So from here, I can say collection.add. And then the add method off the dictionary looks for two things: a key value, a string, and the object itself, which is that user. So to do this, I'll do user, which is the parameter that's passed into the add method, dot email dot address. Comma user. Removes collection dot remove, and what this remove is looking for is simply a key. So we'll say user dot email dot address. Can somebody tell me where the address piece comes from? What is email?
Another object?
Email is a property of our user object.
Yeah.
It's of type, remember the type? Mail address.
Which comes from address.
So address is a property of the class mail address. So if we jump back here, oh, not there, here, I'm just clicking into that data type. I'm going to hit F1. It's going to then launch me into MSDN. It's going to give me the definition for the mail address class, and there's the address property. So because the data type of my email property is mail address, I'm getting all of those properties that come off of that type. So get will be, and we're actually going to return a user, so I'll change my return type to user, and I'll say return collection get and there's a try get value, or we can just use the bracket notation and put the string key in there. So we'll put email address being the parameter that's passed into this function. So this is passed in when it's called. This version of get will be similar. This time we're getting a mail address object. So we want to actually go out and grab an address property of the mail address. And in hindsight, we don't need our interfaces, so I'm just going to drop them. Something that's always nice to have is account. So I'm going to add account property, which will return the count from the collection. Okay. Does anybody sense anything wrong with the add method? And I asked that question because there is something wrong with the add method.
Are you adding user back into itself?
So I see what you're looking at. And the user is there, but so is the email address. So I need two pieces. I need a string, key, and then the value, which is the user. So what I'm doing is I'm taking my user object that's passed in and I'm pulling out the string out of the email address. That's my key value. Then comma, the second parameter is the user itself. So that's the value that I'm putting into the dictionary.
Not handling the exception. There's the same email that's that important.
Exactly. So I call add, put in the user for the first time, works flawlessly, no errors. I call add a second time, using the same email address. The dictionary is going to throw an exception saying timeout, key already exists. So what we need to do is we need to have either an exception handler or we need to be proactive and have some logic to handle duplicates. So exception handling, we could do it here. The question is, if we handle the exception here, what do we do? How should we handle the exception? Should we throw another exception? Which we could. We could create our own exception type, or we could use one that exists. We could throw that with details saying that this collection only allows a unique sets of email addresses and that this email address already exists. We could change our return type from void to a Boolean. So if the add is successful, we return true. If the add is not successful, we return false. Every time you throw an exception, you're putting a lot of work on the computer. Because if you remember from last week, we talked about how you can get stack traces and variable information, and all of that stuff kind of gets packaged up and sucked into an exception object when an exception occurs. So every time you throw or catch an exception, there's a lot of work that the runtime has to go through just to give you that exception data on the off chance that you might actually use it.
So isn't better to use if statement just say
Yes. Yes. So it is better to use an if statement. Try to find a logical way to determine whether or not you're going to fall into a problem.
So the other thing that when you use exception and catch statement, then it just turns off the program, right?
It does what?
Turns off, this quits the program, right?
Yeah.
Right.
Well, if you get into the catch, you can protect it from just quitting the program.
So it allows you to go back and
Yes.
because with if you can do it.
Right. And with the catch, you can as well. If you don't use a try catch, the program will terminate the moment the exception occurs. So you can wrap everything inside of a try, and then if something does occur, the catch will allow you to handle it gracefully. You can log it, you can just ignore it, you can do whatever you want. But as much as you can handle logically using if statements, switch statements, try parse or try type methods, you're better off to do that because then you're not running into the overhead of the exceptions. So if we go the route of using a logic instead of, sometimes I consider it to be brute force, we can say if collection contains key user.email.address tell user else add user. It's much safer, much cleaner, easier to deal with.
So now the approach of how do we tell our user, let's go ahead and convert this to a bool. So we'll return false here. I'm going to actually whack the else statement. And I'll just put return true here. Now, why was I able to drop the else portion? You were right, just say it a little louder.
As soon as you hit a return statement inside the if, it's going to exit the method.
Correct. So, if this is true, it'll enter this if statement, it'll hit the return, it'll return false, and it'll never continue on. You'll never make it down if this is true. If a key exists, you'll never get here. Inversely, if this is false, the key doesn't exist. It will never hit the return statement, it'll add it to the collection and return true.
Sometimes people like to do the if-else, which is very clear. Sometimes it can get very cumbersome. You end up with all the little curly brackets, and they're all over the place. So my convention is make it clear, but at the same time make it clean. So try to limit the amount of curly brackets you have, because then you run the risk of alignment issues. You miss one, you have one too many, your compiler gets pissed off at you, you start deleting them from the bottom. Next thing you know, you've deleted half your code because you just had the wrong curly bracket in the wrong spot. Or more importantly, you can end up with logic flow issues because you end up putting a semicolon here and everything else just continues on. Which I've seen happen and I've done myself. Or you get your curly brackets out of alignment and this code never gets touched in either case because it's after the return. And there is no else scenario. So keeping your brackets balanced and keeping as few of them in there as possible, and that's when you can, is a definite win for you when it comes to debugging your code.
But if you instead of return false, you put the message box, say just fix it.
Yes.
So then you fix the those.
Right. Yeah, but you'll hit the message box, you'll never enter this method, you'll have to enter this method again. So we'll kind of see it as we go through, but this will return false. The form will identify that it was false, that it wasn't added. We show the message box, and then you would actually have a return statement after the message box, which kicks you out of the event handler, gives you back control of the form again.
To the text box.
To the user.
Yeah, that's
The user
what you
makes the
want to do.
change, then they hit add, and then you go through this cycle again. You start over going through the cycle.
But this is what we want, right?
Yes. Yeah.
All right, so we have our collection. We go into form 1. And we want to make this collection so that we have one collection. It's accessible from anywhere within the class. And we want to initialize it so that it's always available to us and it's always ready. So we talk about this idea of scope with our variables. You have variables. You can declare variables inside of a method. You can declare variables inside of a class. Depending on where the variable is declared depends on depending on where the variable is declared, identifies the accessibility to that variable. I always like to think of the curly brackets as the boundaries of accessibility for a variable. So you look at the way that your class is structured. The first curly bracket you hit is the namespace. So it's namespace, CP week 5, curly bracket. The thing defined inside of those is your class. So anything that has access to the CP week 5 namespace can see this class and any other class in that namespace. If we declare a variable inside of the class, the next set of curly brackets, anything within that class, any method, any event handler, any property body specifically, can see that variable. If we initialize it, we now have a variable that is built, ready to go, and we can add users to it, get users from it, interact with it at any point in the code, within the class. If I move it here inside the constructor, now what happens? When I get down here to my add, and I'll drop the public. It's called underscore collection.
Those underscores are just conventional, or is that necessity?
Convention. Yes. So private variables, by convention, you put an underscore in front of them. You're not required to, but it just helps you identify and anybody else reading your code identify, oh, this is a private within this class. I go underscore collection. I get the red squiggles saying that you get this kind of cryptic message of only assignment, call, increment, decrement, await, and new object expressions can be used as a statement. Sounds kind of weird, so I just want to do an add. That's a little clearer. The name underscore collection does not exist in the current context. So somewhere in this file, I declared underscore collection. I declared it up here in the constructor. But it's inside those curly brackets. That's the body of the constructor. Because it's in those curly brackets, that variable only lives within those curly brackets. This method has its own set of curly brackets. Those are boundary walls. The body of this method, button add underscore click, cannot see the variable declared in the constructor. Now I want to make one more point real fast, and then I'll get to what I'm trying to get to. This line is a declaration. It says, create a variable with this name of this type. This line is an initialization. It says, create a new collection, a new user collection object, and put it inside of this variable called underscore collection. You can do them on the same line. So you can declare and initialize an object at the same time. But sometimes you don't always want to initialize the object at the same time it's declared. More specifically, you may want to have a variable have a specific scope, but initialize it at a different point in the application. So as this stands right now, collection still doesn't exist. if I take the declaration for underscore collection and I move it up into the class, making it accessible by anything in the class, the use of it, this is the button add.click method below, or event handler. It's now visible there, and it's visible in the constructor where I initialize it. So when a new instance of my form is created, I want to put a new collection object inside of underscore collection. I want to initialize it in the constructor. But when I get down here to the button click, I then want to have access to it so I can add that new user in. Okay? That's an important fundamental, because what I'm sure you will do, and I've seen it done, is you will declare a variable, you will declare it inside of a method body. You will declare it one time. You will then go to another method body, and you will try to access that variable. And you will get the red squiggle of death. And in that, you will then have to figure out what happened. It'll tell you it's undefined. You go, oh, okay, equals new blah, blah, blah type. So what you've now done is you declared an instance of it in one method. You now created a new instance of a different object in the other method, and you wonder, what happened to my user? I put it in my add, I got to my print, nothing came out. It's empty. How did I lose my user? You lost them because they didn't transcend that boundary. If the it doesn't have to do with where it's initialized in terms of the boundary, it has to do with the declaration as to where that boundary is. So I could move my initialization into my add. What's the problem with putting it here, though?
Every time you try to add, it'll create a new collection.
Correct.
Right to that.
Yes. So you end up with the same net effect. You fill it out, you hit add, it makes a new collection, puts the user in it. Clear the text boxes. Fill them in again, hit add. New collection, add to the user to that collection. The collection you had previously disappears into the digital ether to be picked up by garbage collection and then tossed out of memory. So putting it underneath your constructor or your form load, depending on how you want your program to kind of respond, is your ideal. All right, so we do the add, then we'll clear the text boxes. So let's see, txtfname.text equals txtlname.text equals txtphone.text equals txtemail.text equals string.empty. Huh? So what's happening there?
One equals the other equals the other. It's like they're all the same thing, and in the end, they're all empty.
Yes. Yeah. So it's the algebraic equation of A equals B, B equals C, so A equals C kind of thing.
So remember, these get executed from right to left. So what happens is it says string equals empty, goes into txtemail.text. Take this value, put it in phone, take this, put it in last, first. So instead of writing out
txtfname.text equals string.empty, txtlname.text equals string.empty, you can chain them together and let them all equal each other. And since strings are, I always forget the word, basically since they're not reference types, they're considered value types, you basically are copying the string from one to the other. So you're not ending up where they all point to the same string reference. I can't remember the name, it's going to kill me. That's okay. So if we run this, and do an add, nothing blew up. I do an add, nothing blew up. Didn't get a warning saying bad email address, just nothing happened. I come back. When I call add, I'm not capturing that Boolean. So a Boolean is being returned here, I'm just not doing an if statement. I'm not capturing it to do something with it. So here I'd say if not collection.add messagebox.show error occurred while adding user, verify fields. Email may be duplicate. So we don't exactly know what's wrong, we just know that it didn't add. We know because we wrote it that it's because we have a duplicate email address. But there could be other logic in there at some point that, you know, if there's no first name or no last name, other error checking happens before we add it to the collection. We want it to verify that it's a good user. So there's another argument for having an exception thrown and capturing it, or you can have an output parameter that has details around why it was false. Just like the try parse returns true if it parses, returns false if it doesn't. Parameters are a string in, and then an out parameter, which is the integer. We could do the same convention. We could have a Boolean saying whether it worked or not, and then we could have an out parameter as a string that is the error message if it's false. Yeah.
Every time I try and add something, it's giving me a Stack Overflow exception.
You have a self-referencing. So you have something that is referencing itself. And the stack basically is, you're stuck in an infinite loop, and eventually you're running out of stack memory.
Okay.
So are you doing the same code?
More or less.
Okay.
I think it's slightly more expensive. I may have just done some-
My guess is probably inside of your collection, you're forgetting to call the private variable collection. You're just calling add.
That's supposed to be-
And then it's looping through the add routine over and over and over and over and over. So what you're probably seeing is this. You probably have something more like that. I'm going to put a breakpoint here. If I can find it. Oh, there you go. They changed the tone in 2012, and it's like I can never quite judge where the edges are anymore.
Yeah.
All right, so K, G, 555, me at u.edu, add. So we hit this point in the code. Add is referencing add. So when you call this, it's going to go in here, it's going to pass this user back as this user. So let me add another breakpoint so you can see it. Boom, boom. Call it again. Boom, boom. Call it again. Boom, boom. Take the breakpoints out. This thing just spins up and spins up and spins up and spins up and spins up, and finally you end up with Stack Overflow exception. So that's I'm guessing you've got something equivalent to that somewhere.
Maybe. I'll look through it and find it.
So, and this isn't uncommon that you call methods that you declare somewhere else in your code. It's actually quite common. That's kind of the gist of writing code, is that you build a method somewhere and you call it from another spot inside of the same class or another class. You build private methods that do certain pieces of mechanics, and then you build a public method that calls those private methods to get the work done.
what does happen though is that you'll end up calling something, and usually they're more complex than this. You'll call add, which calls something else, which calls something else, which calls add. So 3 chains deep, you end up calling itself again. So whenever you get a Stack Overflow exception, more likely than not is you have one of these chains that's just iterating over itself over and over again. You end up with a recursive call. Recursive calls can be good. There's actually an entire development paradigm around using recursive functions, functions that call themselves. You basically use them instead of loops. But you also need to make sure that in those recursive functions that you have an exit scenario. If you don't, you end up with Stack Overflows. All right, so it's 7:05. We'll go ahead and take our first break. Do 10 minutes, 10 to 15, when everybody gets back to their seat. And then we'll go through the print piece and talk about that in more detail. I also want to make one more modification to my collection as we go through that, so we'll be touching the iterators at that point.